Okay, we should be live. Be jumping around a few different things. But everything is eventually makes it to BioniChaos.com, so go check it out. Go check it out. My voice is still not 100%, so we will be using AI agents quite a bit. So if you're not into AI, yeah, you're probably in the wrong place. Let's actually try starting a LinkedIn stream as well. I don't know if the previous settings should just work. Yep, failed to connect. Okay. So I need to start it again. It's a different URL and everything. It's like a security thing. Is it a security thing? Let's start it now. Yeah, we now have the CEO Gemini 2.5 Pro is editing videos for us as well. So just give it a link to a long YouTube video. It just chops it up and tells you, it gives you standalone videos out of it. So yeah, beware. A lot of AI content. Oh, actually, we also meant to. We're also using one of our own tools for a camera filter. Yeah, this one here. And doing edge. Pixelate or edge. Let's do 15 frames per second, edge threshold. Let's do 65 for a sec. Does it work? Yeah, it does work. Get this window stretched. Webcam filters. Okay, got it. We are moving somewhere. I have to remember to show the website on a different browser because of the advertisement. So we make tools like this, blah, 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 blah. They're just checking the sound. Oh, let's check this sound.
Question the simulator helps you explore just how much detail can these devices realistically convey.
And that's where the electrodes come in.
Yeah, that sounds good. Okay, what were we doing? It's working okay on Chromium as well. Wait, we haven't started the LinkedIn stream. It's actually streaming. Yes, it's streaming. Need the chat as well. There's like too many things to go live. You wish you could just do it in one button. Surely we could automate everything. But then some of the whatever LinkedIn and stuff would not let you automate stuff. Okay, so we should be live on LinkedIn as well. Am I able to? No, I can't like place comments and stuff. It's crazy. Okay, do we have the sound and everything on LinkedIn? Going to LinkedIn? No. Okay, I'm not sure if the sound is there. Okay, now I'm able to post the... Okay, do we have the sound and everything on LinkedIn? Going to LinkedIn? No. Okay, I'm not sure if the sound is there. Okay, the sound is there. Oh, come on. Becomes ridiculous. Okay, stream. We love problems, don't we? Don't we love problems? Okay, that's probably enough social media I can handle. Just go. Just get on with it. Okay, let's do this. Okay, let's let the bot change for a bit. Just and we'll go from there. Just get on with it.
Welcome to the Deep Dive. We plunge headfirst into all sorts of information, pulling out what's crucial, what's surprising, and honestly, what's genuinely fun, because that helps things stick, right?
Absolutely.
Today, we are navigating the A pretty fascinating world of BioniChaos.com. Now, this isn't just another website. It's an open-source platform making some serious waves in the biomedical field. It claims to democratize complex science, making these sophisticated tools available to anyone with just a web browser. Which, I mean, that sounds almost too good to be true, doesn't it? What's your first reaction when you hear that?
Yeah, my first thought is, wow, that's ambitious. It's a big vision, but, it seems like BioniChaos.com is actually pulling it off pretty effectively in its own way.
Okay.
So our mission today for this deep dive is to really figure out where it fits. How does it stack up against the established, often expensive professional tools? Where does it really shine, especially for you, the learner, and maybe where do the limitations start to show?
Yeah.
Our sources give us a really good comparison, a critical look at its strengths and weaknesses, so we should get a clear picture.
Okay, let's start with that compelling side, then the fun and accessible part, because that seems core to it. The whole philosophy is it's all in browser, no installation needed, zero.
Right.
Just think about that for a second. In a field usually locked behind super expensive software, needing powerful computers, steep learning curves, this just knocks down so many walls.
It really does. It opens up biomedical signal processing to a much, much wider audience. Its biggest strengths are definitely accessibility, education, and this really interactive visualization aspect.
So that in-browser no install thing, it's more than just convenient.
Oh, way more. It's transformative, honestly. Think about a high school student who's curious about brainwaves, right?
Yeah.
Or a hobbyist messing around with biometric data, or even a college student who doesn't have easy access to a fancy university lab. They can just jump right in from pretty much any device with internet. No licenses to buy, no need for a supercomputer, no needing to learn code just to get started. It lowers that barrier to hands-on learning so dramatically. It changes who even gets to try.
And it makes that first try genuinely engaging, which is crucial. Looking through the tools, some are just so creative. Like, get this, EEG music. You can actually take your own brain waves, those tiny electrical signals buzzing around in your head, and turn them into music. I mean, what a wild way to explore auditory patterns from your own brain.
It's pretty cool.
Or the gesture music generator. Make music just by waving your hands.
Yeah.
It's playful, right? But it helps you grasp signal input control. What other tools kind of jump out with that interactive feel?
Well, what's really neat is how they make abstract data feel tangible, instantly, like Cardiobot. Instead of just staring at an ECG waveform, that squiggly line showing heart activity, which doctors use all the time.
The heart monitor thing.
Exactly. Instead of just looking, you're testing your skill spotting abnormal patterns against a robot algorithm. It turns a serious diagnostic skill into a game, basically. Makes it stick.
That is clever. Okay. And I saw one for empathy, too, the vision impairment simulator.
Yeah, that one's powerful. You can actually experience what things look like with, say, myopia nearsightedness or glaucoma, which damages the optic nerve. You adjust sliders in real time to simulate the conditions.
Wow.
It gives you this immediate, visceral understanding of what those conditions are actually like.
That's impactful. What else is in there?
Oh, the list keeps going. There's an interactive hearing test, basically an audiogram that shows your hearing threshold visually, right there on the screen. You can even download the result. For anyone into neuroscience, Seizure Zone is a 3D brain map you can explore, looking at different regions and what they do. Interested in how we interact with computers, the eye tracker uses your webcam for basic eye tracking to explore UI design ideas.
Using just a webcam.
Yeah. And one more, GraphIt. It's a knowledge graph visualizer. You paste in some text, and it pulls out entities and relationships and draws this interactive map. Super useful for seeing connections and information.
So all these examples, they really drive home BioniChaos' core strength, don't they? It's all about that hands-on interaction, getting an intuitive feel for the concepts.
Exactly.
It's not just throwing information at you. It's inviting you to play with it, manipulate it, and really grasp the principles that way. It's a totally different way to learn.
A very active way.
Okay, so we've established BioniChaos.com is approachable, engaging, even fun. Feels like a game changer for beginners.
Right.
But now, let's shift gears. Let's unpack the critical side of this deep dive.
Right.
What happens when things need to get serious? How does it really stack up against those specialized professional tools? Because let's be honest, if you're doing hardcore research or clinical work, you probably need something more, right?
That's absolutely the crucial distinction to make. BioniChaos isn't trying to be a replacement for, a fully equipped research lab setup. It's aiming for a very specific niche, and I'd argue a really valuable one.
Okay.
Let's maybe do a direct comparison to see what I mean. Take EEG and ECG simulation. The tools on BioniChaos, like the Advanced EEG Signal Simulator or the ECG Simulator, they are fantastic for interactivity.
How so?
You can tweak parameters like heart rate or brain frequencies in real time, and you see the waveforms change instantly. That's gold for educational understanding. You get that quick, intuitive sense of how different conditions look in the signals. You learn the signal's language, basically.
So if I'm a student just trying to understand, say, what an arrhythmia looks like on an ECG, BioniChaos is perfect for that immediate visual
or the
feedback.
ECG exactly. It's about building that conceptual clarity. However, if you're a researcher needing to simulate really complex heart or brain activity with super high accuracy, or maybe more importantly, if you need to upload and analyze your own patient data you record, then you need alternatives like ECG Sim or EEG Sim. They offer much more sophisticated physiological models. They're built for heavy-duty data analysis, experimental design, not really for teaching the basics first.
And BioniChaos doesn't let you upload your own data right now?
Not currently, no. Their documentation mentions something called bionicloud.com as a future possibility for that, but it's not here yet. That's a big difference.
That is a huge difference.
Yeah.
Okay, what about something like EMG signal processing, muscle signals?
Right, electromyography. BioniChaos has the EMG hand simulation tool. It lets you visually see how flexing muscles translates into those EMG signals, the electrical chatter from your muscles. And again, it's unique because it's interactive, web-based. You don't need any hardware or coding to just learn the basics.
Makes sense. Good starting point.
Excellent starting point. But then you contrast that with professional software like LabChart or Spike 2. These are often sold with the data acquisition hardware. They offer really comprehensive analysis tools, advanced filtering options, robust data logging.
So built for the real world.
Exactly. Built for capturing actual, sometimes messy, clinical and research data, and then giving you the tools for deep dives into analysis and quantifying things, not just understanding the concept.
Okay. And what about those even more advanced areas, things like FNIRS, that brain imaging with light, right? Or BCIs, brain-computer interfaces, or even cochlear implants?
Yeah, those more niche, complex areas. BioniChaos does offer entry points. There's an interactive FNIRS viewer, a basic intro to BCIs, a cochlear implant simulator, and they definitely serve a purpose.
That's starting points again.
Absolutely. They make these intimidating fields way more accessible. Someone can grasp the basics of an FNIRS signal or how a cochlear implant works in principle without the huge learning curve or the expensive hardware usually needed just to get started with research tools. It lowers that conceptual hurdle.
But for actual research.
For actual research, for real analytical depth, designing experiments, processing actual FNIRS or BCI data, you need the research standards. Things like Homer 3 for FNIRS or BCI 2000 and OpenBCI for BCI development, those are the go-to platforms in the field. They have complete workflows for processing, stats, integrating with hardware and software.
Okay, so the picture is becoming clearer.
Yeah, the critical takeaway really is this. BioniChaos isn't trying to compete head-to-head with established research software. It's not aiming to replace LabChart or BCI 2000 in a lab.
Right.
Its real power, its unique strength, is dramatically lowering the barrier for learning, for exploring, for just experimenting with biomedical data. It's the perfect on-ramp.
Okay, this is where it gets really interesting for you listening in. What does all this actually mean if you're looking to maybe dive into biomedical data yourself, or you're just curious and want to understand the basics? What are the real advantages, and what are those critical limits you need to keep in mind?
That's the core question, isn't it? For someone learning, bionichaos.com offers some really compelling advantages. Number one, accessibility. We've hit this hard, but it's key. In browser, free, no install, works on almost anything. That's huge for anyone outside big institutions or just wanting to explore.
Can't overstate that one.
Definitely not. Second, interactivity and visualization. That hands-on learning, getting immediate visual feedback, it's just incredibly powerful. It helps you build this deep, intuitive grasp of tricky concepts in a way that just reading a textbook can't really replicate.
Feels like learning by doing, which
Right.
always sticks better for me.
Precisely. Third, there's a very clear educational focus. The whole platform feels geared towards learning. There are often explanations alongside the tools, resources, making it great for self-study or even as a teaching aid.
Okay.
And finally, the open source philosophy. It operates under a Creative Commons license, which means transparency, and it opens the door for future community contributions, development, fostering innovation from the users themselves.
Those are some strong positives, especially for beginners or educators. But, like we discussed, there are those critical points, the limitations that stop from being, a full research suite right now.
Right.
The biggest one, for me anyway, seems to be the lack of data upload. That feels like a major hurdle if you're doing any kind of real project. You can't bring in your own recordings, your own raw data to analyze.
You're absolutely right. That's a fundamental difference compared to professional tools. And while they hint at bionicloud.com, maybe fixing that down the line, it's not available today.
Yeah, that's key. What else?
Another big one is the simplified models they use in the simulations. Now, these are fantastic for education because they cut through the noise and highlight the main ideas, but they don't capture the full complexity, the messiness, the variability you find in real-world physiological signals.
Real life is rarely that clean, huh?
Almost never. Which ties into the next point, limited analytical power. It just doesn't have the sophisticated signal processing algorithms, the deep statistical analysis packages, or things like batch processing for handling lots of files at once. These are essential for rigorous, large-scale research.
So it's built for understanding concepts, not necessarily for like publishing cutting-edge statistical findings or crunching massive data sets.
Exactly. It's optimized for clarity, not computational horsepower or complex stats. And that leads to the final point, scalability. Being web-based is great for access, but it might hit performance walls if you try to throw truly enormous data sets or really computationally heavy tasks at it.
Right.
For that kind of heavy lifting, you still generally need dedicated desktop software or maybe cloud computing resources. So these aren't necessarily flaws in BioniChaos. They're more like design choices, trade-offs made to prioritize accessibility and conceptual learning over raw research power.
Okay, so pulling it all together, BioniChaos.com has really carved out its own unique and I think incredibly valuable space. It's not trying to be the next big thing for professional researchers, not yet anyway.
Agreed.
Instead, it's arguably better for anyone just starting out. It offers this super engaging, intuitive, and yeah, let's say it again, fun introduction to what can be a really intimidating field, biomedical signals. It's a fantastic first step, a playful yet critical way to explore. Lets curiosity run wild without the usual roadblocks.
Absolutely well put. And that leaves us with a really interesting kind of provocative thought to chew on.
Cool.
Given how well BioniChaos.com seems to be doing at democratizing these complex tools just for education and exploration, what other fields, traditionally high barrier scientific or technical areas could really benefit from a similar approach, this open source in-browser model?
Interesting question.
How might that model fundamentally change how we learn, how we engage with science, maybe even how we contribute to it in the future? Something to think about as you embark on your own deep dives.
Okay, there you go. There is a human in the loop, so if you have any questions, go for it. But you might want to check the website first. What did we already cover and we are not going into? Synthetic noise generator dashboard. Yeah, go check it out. We're not changing it for now. Leaving it as is. Yeah, got the Cochlear implant simulator. That's probably one of the more useful tools. Meant to scale to the screen. Yeah, it kind of does it. Having trouble sometimes. But go check this one out as well. There should be an audio description on all the tools now. What else we got? The signal generator. EEG signal generator. Yeah, we revamped an older version of this. Oops. It's again meant to fit the screen nicely. Doesn't quite. We should have some new tools as well. We should have some new tools as well. Okay, so let me know if any of those grabs your attention. We can discuss it in more details. Even though, yeah, so we have the professional podcasters discussing it, where you have the audio on the page
So
itself.
typically you see HBO go up and HBR go down relatively.
Yeah, so they're pretty good. Can't do any better than that. So talking is Gonski. Talking is solved by AI.
There's some pretty big red flags, according to the...
Yeah, one of the critical review of the signal quality. And what else we've got? Yeah, let me know if there's any questions. There's a don't like ads. I should be using the other browser. Let's close it in here for a sec. Can use Chrome for production view. Okay, so I have this page. Yeah, don't like the tabs. I don't like the tabs. I don't really like the multiple. I don't really like the multiple tabs. If we can get rid of those, to make it turn it into a single page, a web application, more interactive components would be great. Yeah, Gemini conducted like a deep dive, and now we're turning it into a page, essentially looking for similar tools as what we are developing. And yes, we get the video generation stuff essentially fully automated by, well, not fully, I still have to click buttons, which is unfortunate. I'm not sure why agents can't automate it fully, but essentially if you give Gemini a long YouTube video, it could chop it up for you into pieces. That's what we're doing here with the clips function. So we had a revolutionary way to detect seizures in EEG. That, well, yeah, the title is fine. I trained an AI to detect seizures, and here's what happened. Okay, this one, it's actually a legit title. Even though, yeah, it sounds very, very clickbaity. But let's see, a 5955. Yeah, so it's detecting it's kind of ignoring everything I say. So that's the CEO. You know, if Gemini is my CEO at the moment. and it's just going for everything. The robot is saying, well, essentially another robot, a notebook LM in this case. So it's went from essentially 1 hour to 1 hour 24. That's quite a long one. Not sure I wanted that long, but yeah, it's really just ignoring. It's just biased towards itself. It's just ignoring everything I say. It's also amazing how I lose viewers when I talk myself as opposed to when I have the bot going. Okay, so we have this single, supposedly single page, or not really, could be made a bit longer and single page. You remove the tabs. Well, there's still tabs there in the interactive analysis hub. Yeah, we could make the page longer and get rid of the tabs, if you don't mind. Also, can we place all the interactive bits at the top of the page and all the text at the bottom? So can you redo the whole code, the whole HTML page? Just look at the code real quick. Well, no, we shouldn't be looking at the code because we are vibe coding, aren't we? Yeah, if we want to review something like that, do we just give it the code or all the text? Well, all the text is available on the page, by the way. And we have a JavaScript as well. So what will happen? Give it to a new notebook LM. Just try giving it the HTML as text, and we give it the JavaScript as well. Hopefully it can focus. Do we need to add another text, or should this be enough? Let's do another one. And you can add this as a node. Yeah, it's quite convoluted interface. And then add the node as source. And then you can refresh this page. Let's generate the audio real quick. See what happens. So essentially, you can give it any web page, any web application. Give it the code. I give it the HTML and the JavaScript, which is available on the page itself. Which is available on the page itself. And yeah, we'll generate the overview for us. Hopefully it will be technical enough for your liking. Okay, Gemini is actually doing what we ask, which is great. Not very interactive. BioniChaos philosophy, okay. So it's comparing it to EEG Lab, Brainstorm, and BESA Sim. So accessibility, analytical depth, biophysical realism. Okay. So I score high on this meant to be like a score. So it meant to be like analytical depth, basic, EEG Lab. Okay, that's good to know. Yeah, don't mind it being critical. So accessible, so I score super high on accessibility. Well, obviously, because those are web applications. ECG. Okay, it's actually very interesting. Very interesting. So this is an output of a deep research. We'll make it available on the site. Now in deep research, yes, you can export as PDF for that, but you can also create, we created a web page. Let's try an infographic as well, but let's do an audio overview. So this is from Gemini. It's still using Notebook LM. Okay, let's do another 9 minutes quick. This will be on this EMG hand simulation tool.
Have you ever stopped to think about something kind of fascinating? I mean, with every single move we make, our bodies are generating these tiny electrical signals.
Right, yeah, even just wiggling a finger.
Exactly.
Sure.
From that tiny twitch to, walking down the street, it's all powered by these, like, invisible currents. Today, we're going to take a deep dive into that world, specifically electromyography, or EMG.
Mm-hmm.
And building on that idea, our deep dive today focuses on a really insightful bit of tech, the EMG hand simulation tool.
Ah, yes.
Yeah, and this isn't just like a picture. It's an interactive way for you to really explore that direct link between, say, making a fist or pointing and the electrical waveforms your muscles actually produce.
And that's a really key point, actually. Understanding what it's for is just as important as how it works.
Okay.
So our mission today basically is to unpack how this tool functions, what it's designed to teach you, and maybe just as important, what it's not meant for. And we'll touch on what's coming next for it, too.
And we've got some good stuff to work with. Our sources, they include detailed notes from development, technical descriptions. We even looked at some of the actual code behind it.
Oh, wow.
So yeah, we're getting a really granular view of how this simulation actually, comes alive for you, the user.
Good stuff. So maybe let's start with the basics. What is EMG?
Good idea.
So electromyography, it's essentially the process of capturing those electrical signals we talked about, the ones produced by your muscles when they contract.
Right.
Think of it like listening in on the electrical chatter of your muscles while they're busy working.
It's almost like hearing the body's hidden orchestra, isn't it?
Yeah.
I remember when I first really got that, it kind of changed how I thought about just moving.
Yeah, it's fundamental.
And the great thing about this tool is how it makes that concept real. So it simulates the electrical activity that you would record if you had electrodes placed near the hand muscles.
Right, if you were doing it for real.
Exactly. And what's really neat is how it visualizes these signals, these waveforms showing the muscle activity, and it does it in real time as you interact. That's really the core idea it's built on.
So that's the concept. But how does it actually work for someone using it?
Well, it's surprisingly straightforward.
Yeah.
You've got this hand diagram on the screen, right?
Mm-hmm.
You just click on a finger. That simulates it moving. And when you do that, you see the finger twitch slightly on the screen and bam, instantly, you see a corresponding jump in the recorded signals.
So it's immediate feedback.
Totally direct. A visual link between the action and the electrical result. And if you want to go faster, there are keyboard shortcuts, numbers 1 to 5 for the fingers. Plus, it works on touchscreens too.
And that real-time visualization is, I think, what makes it so compelling.
Definitely.
As you click or tap, you see those EMG waveforms changing live, dynamically responding. Behind the scenes, the code's constantly updating the data, redrawing the signal paths on the graph. It creates this really fluid, live picture of what's supposedly happening electrically.
What's also quite clever is how it adapts the display.
Oh, yeah. How so?
Well, depending on your screen width, it's not just about looking neat. It shows they really thought about the user experience, keeping it intuitive no matter the device.
Oh, okay.
So like on narrow screens, say a phone, the hand diagram sits above just one combined chart showing both electrode signals, saves space, keeps it all on one screen.
Makes sense.
But on a wider screen, like a desktop, the hand's on the left, and you get 2 separate charts for the electrodes, stacked vertically on the right. Gives you a more detailed view, uses the space better.
That is well thought out. And it has different modes too, right? For learning.
Yeah, exactly. Yeah. By default, it starts in demo mode.
Okay.
So the tool just automatically runs through simulating finger movements and showing the signals. Kind of lets you just watch and see how it works.
Right, passive learning.
And this is crucial if you decide to jump in yourself, click a finger, use a shortcut.
You take control.
Demo mode pauses automatically. Then you can switch between demo and user-controlled mode whenever you want. There's a button. Or you can just press the DHEMA key. Lets you learn at your own speed.
Very flexible.
So we've covered how you interact, what you see. But that leads to the big question, right? We're not actually wired up. So how does it make these signals? How are they simulated? That seems like the real magic here.
Yeah, that is the interesting part, isn't it? How does it fake it so convincingly?
Uh-huh.
Well, when a finger gets activated in the simulation, the tool applies specific preset amplitude patterns. These simulate what the two virtual electrodes would be picking up.
Okay, amplitude patterns. What does that mean exactly?
So these simulated signals, they're generated by combining mathematical functions, things like sine waves, but then crucially mixing them with random noise.
Random noise. Why add noise?
Well, that's actually key to making it feel more real. Real biological signals are never perfectly smooth or predictable. They're messy.
Ah, right. There's always background interference.
Exactly. So adding that randomness, that noise, on top of a base signal makes the waveform look much more like something you'd actually record. It also subtly teaches you about the challenges of interpreting real EMG.
Gotcha. And you mentioned specific patterns.
Yes, they've defined specific amplitude values for each finger across the two simulated electrodes. For instance, activating the thumb gives electrode 1 an amplitude of 3, and electrode 2 gets 5.
Okay.
Index finger, that's 5 for electrode 1, 3 for electrode 2. Middle finger is balanced 4 and 4. Ring finger is 3 and 5, like the thumb, interestingly. And the pinky is 2 and 4.
Wow, that's really specific. So those different number combinations, like 3 and 5 versus 5 and 3, that's what makes the signal look different for each finger.
Precisely. These aren't just random numbers. They're designed to create distinct electrical signatures for each finger's movement. It helps illustrate the principle that different muscle activation patterns create unique EMG waveforms.
Okay, that makes sense. It really drives home that different movements produce different signals.
Right.
But this brings up a critical point you touched on earlier. This is not real medical data, right?
Absolutely not. And that's probably the most important takeaway here.
Okay.
The purpose of this detailed simulation, the patterns, the noise, it's all geared towards one thing: providing an intuitive, accessible introduction to the principles of EMG. It's purely for education.
Right. So for someone wanting to learn about EMG, this sounds fantastic, but we need to be crystal clear. You wouldn't use this for any kind of real-world research or, say, medical diagnosis.
Definitely not. It is not intended for diagnosing neuromuscular problems, guiding physical therapy, or anything like that. It's a simulator, a teaching aid. Think of it like a really sophisticated interactive textbook diagram, not a lab instrument.
That's a really important distinction to keep making. Educational tool, not diagnostic. Okay, so what about the future? Where does a tool like this go next?
Well, looking ahead, the developers have a clear vision. The focus is on keeping it simple, accessible, easy to use all on one screen.
Right.
And importantly, keeping it free from proprietary closed source stuff. Openness seems key.
Okay. Any new features planned?
Yeah, the really exciting part is they plan to incorporate other types of biomedical signals too.
Oh, like what?
Things like electroencephalograms, EEGs, brain activity signals, and electrocardiograms, ECGs, the heart's electrical signals.
Wow, okay, so expanding beyond just muscles. That would broaden its educational reach quite a bit.
Massively. Imagine being able to interactively explore brainwaves or heart rhythms in the same intuitive way.
That does sound powerful. Simulating brain activity, though, that must be way more complex than muscle signals, right? Are there unique challenges there?
Oh, undoubtedly. EEG signals are incredibly complex, influenced by so many factors. Simulating them meaningfully but simply will be a big challenge, but the potential payoff for learning is huge.
Yeah, I can see that. And you mentioned keeping it accessible. How are they managing that?
Well, on a practical note, the project welcomes feedback from users, and they also seek support through Patreon.
Crowdfunding.
Exactly. That support helps them enhance the features, improve the visuals, and crucially, maintain it as a free and open source resource for everyone.
That's great. Keeps it available for students, educators, anyone curious, really.
Precisely.
So let's kind of wrap this up. What we've seen in this deep dive is how a cleverly designed simulation can take something pretty complex, like EMG, and make it really accessible and, frankly, quite engaging for anyone. It turns these abstract scientific ideas into something you can actually play with, and understand.
Yeah, it's a fantastic example of interactive learning.
Totally.
And maybe that leaves us with a final thought for you, the listener, to sort of chew on.
Okay.
Consider how tools like this, these interactive simulations, how could they change learning in other fields entirely? Imagine making quantum physics less abstract or complex economic models more tangible. It could really spark curiosity in ways we haven't even thought of yet, maybe fundamentally change how we learn new things.
Well, yeah. Yeah, obviously, I can't do better than the professional podcasters, but do let me know how would you like this tool changed or improved. It will probably go into the next version of it. We'll keep this one as is because it's already out there and running. And we'll be adding those audio podcasts to the page itself, because with audio as opposed to video, I can actually host it myself. Sorry, my voice is not fully back yet, so that's another reason why we will be relying more on bots doing the talking. I can fix a few things on the page. Yeah, and as it said in what's called vertical view, it will overlap the two channels, channel 1 and 2. So that's kind of nice. I like that. Okay, can we add this file as the audio overview of this web application? What will do?
Made changes.
Made changes. Why is it? Yeah, because of the file name. So it's fixing the file name, but yeah. Hey, can we make those components appear in same line on a wider screen?
Made changes.
Did you? Hey, can the page header appear in as one line on a wider screen?
Made changes.
Hey, we don't want it to be in the center and not column, so we want to be arranged horizontally.
Made changes.
It's adding this, yeah.
And what's really neat is how it brings the signals. Kind of lets you just watch and see how it works.
Right, path.
Okay, this is much better. Let's move on. Do we have any questions? No. Not sure if the LinkedIn stream is actually going. I actually forgot to put like a title and description. Oops. So maybe, yeah, the algorithm is not promoting it whatsoever. YouTube does a little bit, but not much. Hey, okay, we had this. We had this. Yeah, this deep dive. Yeah, sorry for that, I'm still coughing and stuff. Okay, we need to download. No, I can't download as PDF. It's ridiculous. It's going on to Google. Hey, whatever it's called. Google Cloud. Loading. Yeah, might take forever. Okay, now we can say export. No, download as PDF. So why not just have it as a function in the original thing? Not sure. Okay, so we created, and what do we have? We have the deep research, We have this interactive web app, which could be made better, but it's essentially comparing BioniChaos to other similar tools, which is nice. Okay,
Imagine this.
We have an audio overview. Let's actually download it. It's only a short one.
Imagine this. You're really fascinated by the human brain, maybe AI, but every time you try to learn more, it just feels like wading through this swamp of data, right?
Oh, yeah. We've all been there.
So today, our deep dive is specifically for you. If you're curious about things like brain-computer interfaces or AI, or maybe you just want a clearer path, a shortcut to understanding this stuff without getting totally bogged down, we're looking at a really interesting online platform. It's called BioniChaos.com.
Right. And their whole mission, they say, is to democratize biomedical data processing, basically making tools accessible, open source.
And that name, BioniChaos, it's not just catchy, is it?
No, it's actually quite philosophical. It points to that, sometimes chaotic result you get when you mix biology and electronics.
That complexity, the sort of messiness of real science.
Exactly. But then the platform itself tries to paradoxically simplify that messiness for learning. It's a personal project, too, which I think is important context.
Okay, so let's get into that. What's the core idea here? What makes it stand out?
Well, its real superpower, I think, is that it's no installation. It's all web native.
None.
Meaning all the code, it's mostly JavaScript. It just runs right there in your web browser.
Ah, okay, so no complex setup.
None. It
Yeah.
just removes these huge technical hurdles, makes these pretty complex biomedical ideas instantly accessible,
That's huge for accessibility.
It is. And the creators really open about it, too. They talk about when things like break in production.
Oh, really? They share the glitches?
Yeah, this whole build-in public thing, it kind of turns the platform itself into this meta-educational experience.
So you're not just learning the science, you're seeing how the science tools get built. The real, sometimes messy process.
Exactly. You see the iteration.
That meta-educational part is, wow, that's interesting. Does seeing that messiness ever feel confusing for a newcomer, or is it generally helpful?
That's a good question. I think because it's framed as part of the process, it actually helps. It shows engineering isn't perfect. It's iterative, builds trust, maybe, and understanding of how things actually get made.
Okay.
And you really see this play out with their interactive tools.
Right. Let's talk examples, because this is where it gets really practical and kind of cool, like the EEG and ECG simulators.
Yeah, the electroencephalogram brainwaves and electrocardiogram heart rhythms.
Forget installing complex software. Here, you can just interactively generate brainwaves, like alpha waves.
Right, the ones associated with being relaxed but awake. Or you can even simulate seizure activity. See what that looks like.
And heart rhythms, too.
Yep, different cardiac rhythms. All right there. These tools are just fantastic for illustrating the concepts, helping you build that basic intuition. What do these signals actually look like?
So great for getting that initial feel, but, and this seems important, it's not for actual diagnosis, right?
Oh, absolutely not. That's the critical distinction. It gives you foundational understanding, which is invaluable.
Yeah.
But it is categorically not for high-stakes clinical diagnosis or serious research analysis.
That's where the heavy-duty tools come in.
Exactly. Things like EG Lab or PM Cardio, those are the industry-standard, validated software packages for real, in-depth clinical work. BioniChaos is the starting point.
Got it. And it sounds like it's a similar story for their visualization tools, like for FNIRS and MRI.
Precisely. FNIRS, that's functional near-infrared spectroscopy, measures brain activity through blood flow changes.
And MRI, the magnetic resonance imaging scans of brain structure.
Right. You can visualize FNIRS data, interact with the 3D brain MRI model, again, just in your browser.
So exploring the data structure, understanding what you're looking at.
Yeah. Again, it's for that conceptual understanding, for visualization, not the heavy lifting.
Not the intense data processing, getting rid of artifacts, segmentation, all that stuff you need for cutting-edge research.
No. For that level of work, you need powerful specialized tools. Things like Homer 3 for FNRS or 3D Slicer for advanced MRI analysis. They really shine there.
Okay. But BioniChaos does dip into AI, too.
It does. And this is really interesting. They have a neural network trainer.
Okay.
It's a brilliant example of their teaching approach. You can actually train a simple neural network right there in the browser.
Seriously, without coding.
Without writing a single line of code. You can tweak parameters like the learning rate, how fast the model learns, and instantly see what happens.
Wow, so you can grasp these abstract machine learning concepts.
Yeah, like overfitting. When the model learns the training data too well and can't generalize, you see it happen. It's a superb interactive tutorial. Really demystifies these complex processes.
So putting it all together, what's the big picture here for someone listening? What does BioniChaos really offer you?
I think it excels as an on-ramp. That's the key idea. Its biggest value is pedagogical teaching.
Right, an outstanding starting point if you want to build that foundational knowledge.
Exactly. Ideal for students, hobbyists, maybe educators, looking for engaging ways to demonstrate these concepts.
And we need to stress this again.
Yes. Critically important. It is categorically not a tool for doing actual research or analyzing real patient data or making any kind of clinical decision.
For those tasks.
You absolutely need established, validated, robust software. Non-negotiable.
So the platform itself helps teach the limits of the tool.
In a way, yes. Understanding that boundary, knowing when a tool is appropriate versus when it isn't, that's a crucial insight in itself. Just as important as knowing how to use it.
Absolutely. So think of BioniChaos as your intuitive guide, helping you understand the what and the how of biomedical engineering.
Yeah, and empowers you to start exploring these really complex fields with, well, minimal friction. Get you started.
Which leads to a final thought, maybe. In this world just overflowing with information, how can you best use accessible tools like BioniChaos, not just to passively consume knowledge, but to really get a feel for the process of creating it?
Mm-hmm. Something to maybe mull over until our next deep dive.
Okay, we'll do a next one. We'll do a next one in a sec. If you have any questions, there is a human in the loop, just if you were wondering. Just if you were wondering. Not actually sure what's the difference between the infographic it's generating to the website. I think I like the website a bit better. I don't know, it's only horizontal bar charts versus vertical. And yeah. There's no interactive stuff to it. Before, when doing interactive, it did the tab, like a tab selection thing. It's meant to be highlighted somehow when you scroll. That doesn't work, does it? And what else you can also do quiz. Quizzes are nice. Everyone loves a good quiz, don't they? So it's the deep research. Create a quiz. Generate quiz. Why not? Yeah, EEG Lab is not really free, is it? Because you need MATLAB. MATLAB is not free. It's giving us a lot of good ideas. Thank you very much. Okay, let's do a quiz. Shall we do a quiz? According to the report, what is the primary philosophical difference between BioniChaos and the EEG Lab? Must be this one, whatever that is. Show hint. Yeah, I like it. The analysis concludes that BioniChaos' greatest strength is also the source of its primary weakness. What is this? The core? I think something about uploading the data. Is it this one? Yeah, it's being a bit too dramatic, I reckon. The first year neuroscience student wants to visually understand the difference between, well, of course I'll say BioniChaos. That's right. Thank you very much. Yeah, the quiz is obviously biased towards one tool. A researcher has collected 64 channel. I would say BioniChaos. The researcher has collected 64 channel EEG data and needs to perform independent component analysis. Well, no, just say use an LLM. I would just say use Gemini to write Python code that will do it. And that's essentially what we're showing on this YouTube channel as to how you could do it essentially yourself, well, with an agent. When comparing BioniChaos ECG simulator to the clinical AI tool BMCardio, I'm not actually familiar with it. What is the fundamental difference? Can simulate more cardiac rhythms? It's free. I would say that. No, I was wrong. Illustrates that ECG looks like while being analyzes real patient data. Okay. What essential analysis step crucial for a meaningful FNIRS research? Yeah, blah blah blah. Yeah, I don't like this. It used to be, it was to begin with, it was highly biased towards BioniChaos, but then it's not anymore. So. No, I'm joking, of course. Yeah, should check out all these other tools as well. Well, there's the EEG Lab Brainstorm BESA Simulator. BESA Simulator, that's just for EEG analysis. Then for ECG, you have ECG Sim, Skill Start, BMCardio. I haven't actually tried them. For FNIRS and MRI. You have Home of 3, 3D Slicer, Mira. Yeah, go check them out as well. Yeah, I'm not sure this bit is relevant. Yeah, the trainer was just a very basic example. Yeah, can't really compare it. Ease of use, yes, just a single button. Trading. Yes, so very interesting. We might make it available on the page. It's really funny how I start losing how I start losing viewers when I talk. Yeah. And I'm not sure what happened to the LinkedIn stream. I think I didn't set it up correctly or something.